Welcome to the Humanoid Bioprinting Lab. You are in the year 2030. This is a virtual tour experience of the lab. Sit back, relax, and welcome to the future. If you proceed to the left, you will enter the Humanoid MRI Scanning Center. If you proceed to the right, you will enter the Humanoid 3D Bioprinting Lab. If you proceed forward, you will enter the Humanoid Showroom. Please proceed in the direction in which you would like to learn more about. It starts with a patient's own cells and ends with a 3D bioprinted organ. The humanoid bioprinted organ's replacement process begins with a magnetic resonance imaging, also known as an MRI scan. This procedure is used to create a detailed 3D image of a patient's organ. Using this image, a computer software program will construct a digital model of a new organ for the patient, matching the shape and size of the original. A bioink is created using the specialized organ cells combined with nutrients and other materials that will help the cells survive the bioprinting process. The bioink would then be loaded into a bioprinter, a highly specialized 3D printer designed to protect the viable living cells during the printing process. Bioprinting is done with a 3D bioprinter that is fed the dimensions obtained from the MRI. After printing, the organ is then matured in a bioreactor, conditioned to make it stronger and readied for patient transplant. A successful patient transplant would then be possible and carried out by a transplant surgeon. Given the original MRI and blood sample, the new organ should be both a precise fit and a perfect genetic match for the patient, free from the risk of rejection or the need for immunosuppressant therapy that has plagued conventional organ transplant methods. A typical kidney transplant can cost more than $300,000. 3D printing reduces that number to less than $50,000. Every year the number of people on the waiting list for an organ transplant increases, yet the amount of donor and available organs remains low. "3D printing applications in dentistry has helped in a variety of different ways, from orthodontics to general dentistry. The different dental areas currently integrating 3D printing are fabricating customized and accurate braces, dental restorations, castable crowns, dental bridges, and denture frameworks and bases. 3D printing in medicine has helped the dental health field to offer convenient chairside care at a lower cost and with a controlled treatment plan. It also minimizes the wait time because no mold is needed, the feature can be printed directly. 3D printing in medicine is helping in the development of prosthetic limbs. Traditionally manufactured prostheses have been known to be very expensive and uncomfortable for the amputee. 3D printing is tackling these worries. The ultimate goal is to design comfortable prostheses that both suit specific patients' needs and are also cost-effective. With the many projects on 3D printed prosthetic arms and 3D printed prosthetic legs, this goal is already becoming a reality. Great work has been done in providing prostheses or replacing limbs to war refugees and many others injured from natural disasters, as well. It brings much hope and joy for both the medical practitioner and the patient that there finally is a feasible solution within reach. Tissues and organs can now also be 3D printed. This is especially exciting and applicable for the field of transplants, as it solves any moral and ethical issues that may be tied to traditional transplant methods. It also increases acceptance as customized organ development utilizes the patient's own cells. Skin tissue repair and reconstruction, limb replacement, kidney transplant, and heart transplant, among others, are being successfully achieved thanks to 3D printing in medicine. Being able to 3D print tissue cells and organs has promoted research work for diseases like cancer to study how tumors grow and develop with the intent to find a cure.